In this video, we're going to go over another common type of tricky algebra problem involving what I call puzzle pieces. Now, we're going to start with this warm-up. And also, for this video, for these 1 through 3 problems, if you're not really good at expanding and factoring, such as these things right here, you have no business even attempting these, and you need to go back to the expanding and factoring videos. So if expanding these is super easy for you, then you're ready to do these. All right, so let's start with this one. X squared over 4 equals y squared over 5, and the question is, what is negative y over x? This is just meant to illustrate one point, which is we don't have to find x and y to solve this. So for the rest of these problems, the tricky approach will involve using puzzle pieces where we don't even find the x's and y's, we just work with the big pieces rather than the little details. All right, so we're just gonna rearrange this, move the x squared here, move the 5 over, and that's it. So we're gonna have y squared over x squared. Now I'm gonna write the right side on the left just because that's the question, but if we're moving this, you would actually have 5 over 4 equal to y squared over x squared. So I've just reversed the order. All right, so we found y squared over x squared. So now we just take the square root, and so y over x would be plus or minus the square root of 5/4. And since we want the negative of that, well, it doesn't matter, does it? We'll just have minus plus instead of plus minus. It's all the same stuff. All right, so the point here is we don't know what y and x are, but we did manage to find this expression as an exact value, right? So we don't have to know that y is 7 or x is something else. So that's the idea here, just that we were rearranging. All right, so that's the first. That's number 0. All right, so this is our first real problem. And keep in mind, these problems, this puzzle piece stuff here and the previous videos on symmetry, that's really what I consider the heart of tricky algebra. We'll see a lot of other problems, but just know that those are the core problems. All right, so for this problem, we've already seen this under substitution and combination with systems of equations. So you could just add the equations and get 2x equals 7. And from here we could find x. We could subtract the equations, the x's will cancel, and we'll get y minus a negative y, so that's 2y. 4 minus 3 is 1. So we can just find x and y directly from here. So that's actually probably the fastest way to do this problem. I purposely want to show you the tricky approach to find, now remember, we want to find x times y, so we're not done here. We would multiply x times y and get 7/4. Okay, easy enough. But I want to show you how to do this using another method. Now keep in mind, just because you may know some tricky methods, this is a great example of simplicity working best. Our old approach of just combining them worked perfectly fine. So if you try a tricky approach on this problem, you're probably wasting your time. So here's the tricky way of doing this. If we square this whole equation, that involves knowing what that is. So that's x squared plus 2xy plus y squared. Again, if you're wondering how I got this, you need to go review expanding and factoring. So that's 16. Squared this whole equation. So far it looks like I've greatly overcomplicated the problem. Except if you're very comfortable with this is not too bad. So now what we're going to do is subtract these entire equations. Why are we doing that? Because these will cancel. And we're going to have a negative negative, so that's going to be 4xy from the 2 and 2. And that's going to be a 7. So xy is 7/4. Now keep in mind, you can almost do this in your head. I'm just writing this out so you guys can see the work. We got the same answer using a tricky approach, which is we never even found x and y. That's the key point here. We just worked with the expressions, the puzzle pieces. All right, so that's number 1. That's our theme for all these problems. So for number 1, we could have done it the traditional way or this tricky way. For number 2, if you try the traditional way, it's going to be kind of annoying. So let's try substitution. So we'll do x is 4 minus y. We could plug that into here. So that's 4 times that times another y equals 6. And then if you multiply everything out here, and rearrange it, This is not too terrible, but this is a quadratic equation, so you would need to either factor this or use the quadratic formula. The point is, these numbers don't have to be very nice, so this is a little bit of too much work to solve this problem. So there's a much more elegant solution to do this. So the elegant approach involves thinking of these as pieces. We're trying to build what we want out of what we have without even getting x and y. So since these are squares, you should be thinking of squaring. So if you square this one, you get that. Now notice, these are kind of maybe similar. It's actually, whoops, I apologize greatly. That should be x squared plus y squared over there. Otherwise, this problem is a lot more annoying. All right, so we're trying to find x squared plus y squared. Notice if we square this, we don't quite get that. We get this, what we want, plus some junk. But we know how to get rid of this junk because we know what the xy stuff is. So if 4xy's are 6, then 2xy's must be 3. So all we have to do is subtract 3 from 16, and we're left with just what we want. All right, so that's another example of just working with the pieces, not even finding x and y. That's what makes this a tricky algebra, tricky approach. And this is kind of in the spirit of combining equations. All right, number 3, again, same idea. We have x squared plus y squared is 4, and xy over 2 is 5. So how can we use these pieces to create that? Let's expand this first. Now looks a little bit better. We already have these parts, and we can get this very easily. If xy over 2 is 5, so that means xy is 10, and negative 2xy is negative 20. So we don't know what this is. That's what we want to get. But we know what this thing is. That's 4. So how do we go from this to that? All we have to do is subtract this middle term right here. So we can just take the 4 and subtract the 20, which corresponds to this piece right here. Negative 2xy is negative 20. So 4 minus 20 is negative 16. And we're done. So again, to recap, all these problems involve using these puzzle pieces and not even drilling down to the equations. If you try to actually solve for x and y here, you'll have a bit of a tough time at best. You'll either be able to do with some trouble or you'll just get stuck with some crazy algebra equations. All right, I'll see you guys in the next video.